So I was doing a problem the other day with a student, and it was a sphere, and it was just huge measurements. And I kind of jokingly said to the student that would never happen. There's never a sphere that would be that big. And then I realized there was the Death Star from Star Wars. So in honor of the biggest sphere ever, we'll do some Star Wars for the review. Shout out to my favorite Star Wars hero of all time, the ultimate balance of power, Darth Vader. So here's a clip to start the Darth Vader homage Unit 10 review.
No way. I'm not paying you. This is ridiculous. Every hole, it's the same crap.
Hey, don't. I wouldn't.
So clearly not someone you want to play golf with. He's a big cheat, but that's all right. So algebra review, I figure you need to see these done because I'm kind of sick of you guys missing them. -3 times -6 is 18. -3 times 8 is -24m. Greater than or equal to 4m plus 18. Alright, I'm going to get common things on the same side. I'm going to add 24m over here. And at the same time, because I'm fancy, I'm going to subtract 18. Alright, so we have this line down here. Nothing's changing here. 4 and 24 is 28m. And that's gone. That's gone. -18 minus 18 is 0. Divide both sides by 28, and come on now, that's going to be an easy one. M is less than or equal to 0. Over here, distributed negative, -m minus 6 is less than or equal to -7 minus m. Add my m's, get those together, and we get -6 is less than or equal to -7. Is -6 less than -7? No. Is it equal to -7? No. So this is no solution. Alright. Alright, find the equation of the line. So that's y equals mx plus b. M is our slope. We need 2 points. Look, there's one. Look, there's one. So, up 1, 2, 3, 4. 1 is or -1, I go to the left, so my slope is 4 over -1, which is -4x. My intercept is right here, -5, so -4x minus 5. Alright, come down here. Factor completely. The first thing you need to do is look to see if there's any greatest common factors. If you're not sure, you can start with the smallest number, get some factors going. Alright. See what goes into it. Does 24 go into 90? No. Does 12? No. Does 8? No. Does 6? Yes. So I take a 6 out. So 4x squared, because 24 divided by 6 is 4. 90 divided by 6 is 15. And 54 divided by 6 is 9. Now I'm going to factor that. First times last is 36. And I need it to add to 15. Well, that's 12 times 3, and since there's a leading coefficient, I need to do the box, unless you know another method. Some of you do, which is awesome. So I got 4x squared, 9, and now I got 12x and 3x. Greatest common factor going this way is 3. Greatest common factor going this way is 4x. Greatest common factor going this way is 3. Greatest common factor going this way is x. So, don't forget our greatest common factor at the beginning, x plus 3 times 4x plus 3. Alright. Over here, I'm going to factor out a 3. That's x squared minus 16. This is the difference of squares. I know this one because it's a minus and there's a missing. I know it's automatically going to be the square root of these numbers. Alright. So, it's going to be x minus 4 times x plus 4. If you didn't know that, you could have done the x. -16, and there's no middle term, so it adds up to 0. Over here, start at 4, down 1 over 2, down 1 over 2. Looks a little bit like that. I'm going to start at -2, up 1 over 1. And it's pretty obvious that it's going to meet right here, and that point is 4 comma 2, and that is necessary to write. That's the solution. All right, so that's a little algebra review. Before we get into this, let's see how Darth is at fantasy football.
Round 2, TK421.
Fantasy owners with 3 receivers averaging at least 1,000 yards are more likely to emerge victorious. I'll take a wideout.
Impressive.
I shall now select a kicker.
Kicker.
I find your lack of faith in my selection disturbing.
My mistake. Good pick. See you in the playoffs.
Can't wait.
All right, so not very good at fantasy football either. No problem. All right, so prisms. I'm going to do some of these and talk about some common mistakes. First of all, these rectangular prisms are one of the most often missed. Okay, you need to pick which side is going to be your base, your big B. Doesn't matter on this because any of them could be parallel to each other. On a triangular prism, for example, this has to be the base because it's the only 2 sides that are parallel to each other. Over here I can pick, and I often recommend to students, kind of shade it in. Shade the 2 bases in so you know, so you don't make a mistake. Because when I do surface area, and I do the perimeter times the height, plus 2 times big B. Big B is always the area of the base. In this case, it's length times width. I need to know what these are referencing. So what is the perimeter of my base? Well, it's 4 plus 5 is 9, so that's times 2, that's 18. The height of my prism is always the distance between the 2 bases. Cannot believe how often that was missed. Over here now, again, this is referencing my base. Length and the width of my base, 4 times 5. And I am not going to even bother doing that out. You can do that. All right? Volume. Volume, big B, again, big B is area of the base. So that's length times width times the height. All right? Length times width of the base, 4 times 5. Times the height of the prism, the distance between the 2 bases is 11. And again, I'm not going to waste my time. You can multiply that out. All right, so over here, same things, everything's happening. Surface area is the same thing, all right, plus 2b. Now, the only difference is this is a little bit different formula. That's the area of a triangle, so 1/2 base times height. Now, I completely understand that this is an H and this is an H, and they are not the same thing. You don't understand that a lot of times, and you need to. This is always big B, the base. This is the height of the prism. So what is the perimeter of our base? 6 plus 4 is 10, plus 5 is 15. Times what's the height? What is the distance between the 2 bases? 4. Plus 2 times 1/2. And again, yeah, those are going to cancel out. The base of our triangle. That's important is where it's the right angle, so it's 6 times the height, 1.6. All right, and you can multiply that out. If I was doing volume, again, it'd be big B times H. It'd be 1/2 the base of the triangle times the height of the triangle times the height of the prism, 4. All right? Again, I'm getting tired of you guys missing that. Those are easy, too easy to miss. All right, perimeters and cones, very similar figures. Let's take a look. All right, so the surface area is 1/2 the perimeter of the base times the slant height plus the area of the base. This time we have the area is a regular hexagon. All right, so 1/2 the perimeter, 8 times how many sides? We got 6, so that's 48. Now we have the slant height. The slant height is this on this side. And sometimes you're going to have to use the Pythagorean theorem here. So again, this would be C. So C squared equals 11 squared plus 6.9 squared. And then you would take the square root of that. So C would be whatever the square root of 11 squared plus 6.9 squared is. All right, and that would go right here. Plus 1/2. A is the apothem, the distance from the center of the hexagon to the side perpendicular. That's 6.9 times the perimeter, again, 48. And hey, big boys and girls, you can multiply that one out if you'd like. The volume, 1/3. Remember, 3 of these pyramids fit in a prism, times the area of the base, which is 1/2 AP, times the height. And the height here is the perpendicular distance from the vertex straight on down. All right, so that's 1/3 times 1/2. You know what kills me? It bothers you that you guys have these fractions. You have a calculator that does fractions. As if you couldn't do this one enough, it's a piece of cake, your calculator would do it for you. Hit the math frac button. Times the perimeter, 48, and the height there is 11, and you can do that one out. All right, same thing here. We got all the same thing. You'd have to find the height for the volume here. So this would be C, so it would be, the height would be, let's see, H. So we would do 20.1 squared is going to equal 9 squared plus H squared. So you'd have to subtract 9 squared, so you get 20.1 squared minus that would equal H squared. Take the square root of that. All right. So that's really the only difference. You plug that in for H here. All right. Otherwise, it gives you the slant. Everything's the same. I don't need to do that. I don't think. Waste your time. All right. Spheres, we have 4 pi r squared. Come on. I mean, this is a piece of cake. That should be a pi. 4 pi r squared is going to be your surface area. Multiply that out. Your volume, oh no, a fraction. I'm going to freak out because I have a fraction. No, come on. These are too easy to miss, and people are missing them, and it's really kind of bothering. All right? Let's take a next look. Look up here. Mr. Kelly, deleting my files. All right, so a square pyramid has a surface area. So I'm going to start. Surface area of a pyramid is 1/2 perimeter times slant height, right? Plus the area of the base. The area of the base of a square is side squared. Now look at this. Perimeter of a square. I have 4 S's. So 72 equals 1/2. Perimeter is 4S plus, or excuse me, times my slant height here is 3 plus side squared. All right? So 72 equals, half of 4 is 2. 2 times 3 is 6S plus S squared. You need to get this on the same side so you can solve it. S squared plus 6S minus 72. Again, you need to factor that. However you know how to. Set them equal 0 and solve them. Can I have a negative number on this? Can I have a side that's a negative number? No, I cannot. All right? Down here, surface area of a sphere. I always start by writing out the formula. It's just too easy not to. And it cuts down on mistakes tenfold, I guarantee you. So then I go back and I put in what I know. All right? Then I go back and I divide what I know. Okay? So let's see, what's that going to be? R, so that's 36. So R is going to be 6. All right, now, you got to be careful here because it's not asking for R. It's saying, what is the sphere's volume? So then you take that and actually plug it into 4/3 pi R cubed. Okay? Then you spit that out and you get the volume. Let's talk about applications. We got 2 types of applications mainly in this section. We got composite figures. So, in other words, you have to take the surface area and volume of this. All right, you're going to add 2 things. But you have to be careful. If I do surface area of this, I'm really going to take, I'm not going to take, there's like this, you know, this square here lies between the 2, right? It lies between the 2. I don't ever need the area of that. So when I do the pyramid, I'm really going to do, you know, just the lateral area of the pyramid, aren't I? And then I'm going to add to that, now I normally have 2 B's, so I'm really going to add the the lateral area of the prism plus just one big B that time. All right? Now volume, does anything change with volume? No, volume, I'm just going to add the volume of the pyramid plus the volume of the prism. Okay? The second type of problem we have down here it is a problem I describe as how many times would it go into it. All right? So in this one I have a Lego house, and it talks about the Lego house. And we want to know how many Legos. Then it has one Lego. All right? And the Lego is just one little piece of this. So I need the area of this Lego. And it's going to tell me, all right? And then I need the surface area of this house. And I'm going to figure out how many Legos I actually need. And how I do that, I do, the house divided by each Lego. And these are the areas respectively. Then it'll give me an answer. Now, here's a trick. Say my answer is 100.1. How many Legos do I need? Well, a lot of you round and say I need 100 Legos. That's not right. If I need to get this 100.1, 100 won't cover this extra. This is not a rounding situation where I round down. I would actually need 101 Legos. Okay? Alright, so there you have it. And our homage to Darth Vader wouldn't be appropriate unless we have him playing a little soccer. Alright, good luck on Unit 10. Finish out the year strong. Sully out!
T'es complètement fou, mais qu'est-ce que tu fais?